Alright, in this video I am going to interpret the slope and y-intercept and also correlation again. I think you can see that in a previous video, but I'm going to do it again. So we were looking at these Gesell scores and age of children when they spoke their first word. And we had all this data output and a scatter plot. Let me go back through how to get the data output. So on your calculator, type in all the data, make sure you name your lists, and let me freeze it here so you can pause it and type all that into your calculator if needed. And then on here, it's already typed in. So you go menu, stats, stat calc, and we picked the fourth one in here. And all you do is type in the names that you named your variables. I named them A and B. And you get your data output. So we already talked about R in a previous video. And R squared we have yet to talk about. We'll talk about that probably on Thursday. Here is our slope. And notice there's a B right next to the X. So if you forget what variable equals what value, like what is B? Is that slope or y-intercept? Right above it up here there's a B right next to the X, so that has to be slope. And then the A is all by itself, so that has to be y-intercept. Okay, so let's interpret both. So down here it asks you to interpret R, slope, and y-intercept, and let's actually start with R. That'll be review. I got an R of negative 0.6403. So make sure you use context when you do it. We can say age of child at first word and score have a correlation that is negative, well, let's say that is a, sorry, that is a negative, moderate, linear relationship. All right, hopefully that was review. And then let's do B, which is our slope. Let me change colors so it stands out. So that was negative 1.127, 0. And that's our slope. And you already know about slope from Algebra 1. It's rise over run. You just got to talk about it in regards to the context. And since it's a fraction, slope, rise over run, let's force this to be a fraction. So put a 1 under it. And now we have a fraction. So remember, change in y over change in x. So I'm going to talk about the negative 1.127 in regards to the change in y, or the change in score. And the 1, I'm going to talk about the change in x. It is a form of an average, so I lead with that. On average, and I kind of vary in how I do this every time. It doesn't matter if you talk about the x first or the y first, but I tend to talk about the x first. So, all right. On average, as age in months increase by 1, or maybe for every 1 month increase in age. Now I'm going to talk about the change in y. There is a decrease of 1.127 in score. So I think that's fine how I wrote it, but I like the way I said it that second time. So every 1 month increase in age, something along those lines. As long as you attach 1 to x and the actual slope is attached to the y, you're safe. You got it. All right, let's describe y-intercept. So that was A, and that's 109.874. And one thing to always ask yourself is it plausible in this circumstance? So y-intercept, that's when x is 0, right? So that would be 0 months. The child would be 0 months old, speaking, and have a score of 109. Doesn't really sound plausible in this case. So we can still interpret it, but at the end, I'm going to say not very plausible or not likely to happen. I guess it's possible. Maybe that's happened sometime in life, but the y, or let's say, a score of 109.874 at 0 months for first word spoken is not plausible. And if you feel like you need to explain more, you can, but I think that's enough because children will most likely not speak at 0 months. Unless you count screaming or something. Okay. Hopefully that works. Hopefully it makes sense. I will see you in class.